Hello all, Reality Stop here. I wanted to do a video tutorial on the RTS camera macro that I have developed, and I've been putting up a tutorial on the forums for several days now, but it's gotten to the point where even I'm having a hard time telling where in the macro library that we're building I'm editing in these screenshots that I'm posting. Even if I explicitly state it, it's not necessarily immediately obvious to me where I'm sending the user. And because we're solving lots of problems, we're going back and forth and back and forth and back and forth. And so I feel like a video tutorial on this might be more helpful than the text tutorial, simply because you're going to be able to see the context changing, both in terms of what you visually see and also as I talk you through what I'm doing. A step that might be kind of a sentence on the tutorial on the webpage, which is a very nice condensed version of the information, is not as informative as if you see me actually building the logic, you see me navigating around and going in the graphs, and you see me building all the graphs that I'm talking about. So I think I'm going to do a video tutorial series on this. Hope you stick around for all of it if you're interested in it. We're going to go through the whole process from start to finish. Of course, I've already developed this. I have on my other monitor the built and working version, and then on this monitor that you see here, I'm going to be actually going through the process. So what I've done is I've built a little test scene here that really is just supposed to be just a few planets here orbiting around a sun, and I think I have a little starbase orbiting around one of the planets. This scene and the graphs that I use to build this scene are available or will be available in the tutorial, the text tutorial where you saw this link, or in the description down below. So regardless of how you found this tutorial, you should be able to get access to those files. So really all it is here, let me just go ahead and fire this up. And you're going to see really not very much here. But if we go back to the scene, you'll notice that we have a star here, and we have little planets orbiting around the star, and their orbit is faster if they're closer, so you get a really fast orbit on the starbase, and we probably can't even see anything because here we haven't set up our camera. That's what we're here to do in this tutorial, and so we're gonna have to see the scene to see that stuff happen. But that's the starting scene. If you have your own scene that you want to add this to, feel free to use yours. I'm just doing this, and the numbers that I'm going to be using and tweaking are numbers that are for this particular use case. You know, you might be a lot closer to your game. The units you might be using might be totally different. But this is the little scene that we're going to be using in this demo. Yeah, there. You can actually see the planet going behind the sun and this little starbase whipping around so fast that everybody would probably, get launched out the side of it. But never mind. If you are just coming into Bolt, you're looking at this from a standpoint not necessarily of just learning how to do this particular camera in Bolt, we're not going to be covering the really basic stuff. So if you haven't done the basic tutorial that is built, or not built with Bolt, but is built into the Bolt documentation, it's that 2D platformer, I would heartily recommend that you do that one, because they cover all the basic stuff. It's really going to give you a foundation in what graphs are, what's the difference between state and flow graphs. It's going to tell you how to create a super unit. It's going to tell you how to set up events and how they work, and how to add units and how to find things, how the variables work. It's going to teach you all of that I'm not going to be going into as much depth in this video on. I would heartily recommend you go do that tutorial. After you've done that, if you want to come back and pick up here, then hopefully I'll go into the depth that's necessary to cover the additional topics, the things that aren't covered in the platformer tutorial, as well as why I'm making the decisions I am making, because there are some nuances when it comes to making a camera like this that may not be immediately apparent if you've never tried to do it yourself before. But enough of all the basic stuff. Let's go ahead and open up our graph view here. Now, I'm going to be using human naming for this tutorial as opposed to the programmer naming, but that's both for consistency if you've just gone through the platformer tutorial, as well as if you are well, kind of a starting programmer with Unity or with visual scripting, you may not be as familiar with the programming side of things, but also for me, I find it much easier to find things via searching with the human naming as opposed to the programming naming, which is funny because even though I know the exact name I want to access, I haven't figured out how to get the programmer naming finder to give me properties in the way that I expect. So if I want to get a property, instead it starts returning all sorts of things that I don't want. A bunch of getters and setters, whereas with the human naming I can say get and then property name, and I can select exactly what I want and get fewer options. So that's why we're using human naming, which hopefully is more consistent with what you've seen, and hopefully if you're a programmer you can just do the switch in your head because you know the routines that I'm invoking if they are built into Unity. We're also not going to be using any custom code. You certainly can use custom code, but we're not going to be doing that here. So let's go ahead and just quickly skim over what we did and what you will get if you go download the scene setup from either the description or from the Bolt forum. And what you're going to get is a script here for the, let me just show you. You're going to get 2 scripts. Just kidding, you're going to get 1 graph, not 2. Apparently I hadn't deleted the old one. And this is the logic right here for the orbiting. Now there's built-in embedded graphs in this logic. You can see here that I apologize. This is going to get ugly for a moment. Ugliness. Okay, that's as ugly as we're going to get right there. That we're not going to get that ugly again. What this is it's just a very simple orbital system where if you put this flow on a game object using a flow machine, then what it will do is it will look up the hierarchy for an object that has is celestial body set to true as an object variable on it. And we have done that on our star here. If I turned this off, then the planet wouldn't orbit anything. Instead, it would just sit there. It wouldn't generate any errors, but it would just sit there, and the starbase would still orbit around the planet, but not around the star. So that's what happens here at startup. It comes in, finds a celestial parent, and then sets some default variables for us. This is not any, advanced physics or anything like that. It's just take a look at how far we are from our host. If the orbit distance hasn't been specified, then just take a look at how far we are, get the magnitude, set that as our distance. So we can drag around in the scene graph, and as long as we haven't overridden that variable in our variable list, it's going to use that scene position to tell it how far away from the parent celestial object it should be. Likewise with the orbit time, you're going to recognize this is very similar. If there isn't an orbit time, then go ahead and look at the distance and do kind of some fuzzy math that of course is not physically accurate and set that as its orbit time. The goal there is just the farther away from its host it is, the longer the orbit takes. And likewise, we're going to use the current position to figure out what our current angle is, so that then down below in our actual update, we can adjust the angle using some math, which we're not covering here. We're going to encounter some of this math later on when we're working with the camera, but you can look at this logic all you want, and you can see the math that we're doing. And then some other ugly logic coming around here, we're actually setting position. That's it. We have our startup, find the host, set some default variables, and then we'd have the orbit itself. So that's what's producing this behavior in the scene. And we're not going to visit this, we're not going to be tweaking it, and we're not going to be doing gameplay in this tutorial. We're only going to be going over an RTS camera. So what is an RTS camera? I probably should explain this a lot earlier in the tutorial video, but an RTS camera is not a camera that is only used for RTS games. It's just that almost all RTS games use this style of camera, so we're using this term to help you, the developer, look at it and go, oh yeah, I know what that type of camera that is, I know what behavior it's going to have. An RTS camera is an overhead camera that's only moving really in the XY plane. You can zoom up and down, but all of its panning and movement is confined to the top down. In other words, the user can't change that perspective in a 3D sort of way, something like Homeworld or something like that, where it's a 3D world and you can get below ships and above ships, and we aren't doing that. Instead, think more like StarCraft or Dota or every Age of Empires, all those RTS games use this overhead fixed camera. And in fact, a lot of other games do as well. But the RTS specific has a couple different camera control mechanisms. So in the normal state, we want to be able to pan the camera either with the keyboard or mousing over to the edge of the screen, or maybe pressing a button and then moving the mouse around, causing the camera to pan around. We also want to be able to zoom in and out. And also we want to be able to rotate the camera potentially. If it's a 2D game, obviously we just turn that off. If it's a 3D game, then we want to be able to rotate around, still keeping that overhead perspective, but be able to rotate around. And then the last thing that you really kind of want to do is be able to limit the distance that the camera can travel. If you're playing an RTS, then you have some sort of map and you want to confine the camera to that map. But that's not all you may want to do. That's kind of the normal camera operating mode, but you may also want to be following a unit around on the map. Or you might want to be able to freeze the camera. If it's a competitive RTS, you may want to be able to have, say, somebody paused the game or somebody opened an options menu or something. You may want the camera to freeze while a UI is open. Maybe it's something as simple as they opened up a tech tree or something like that. And you want to pause so in the background the screen isn't scrolling around as the player's mousing around in this menu. So those are kind of the control schemes that we're going to develop over this tutorial series. So to start out with, we're going to follow a strategy that allows you, the developer or designer, to set in your scene the camera basics. In other words, what the starting position is, and be able to set the properties, but allow the script and the logic graphs to take over anything that you haven't taken care of. So other than the position, we're gonna keep the position that the developer sets of the camera. We're just going to set the Y position and maybe the rotation. For the purpose of this tutorial, we're going to keep a fixed top-down perspective. We're not going to have one of those that kind of sweeps as you zoom in, which is a common thing in 3D games where when you're viewing from overhead, you're looking down. As the camera sweeps in and you're zooming in, then you get a much more horizon shot of the action. Not full horizon, but it definitely extends so that the user can see farther. We're not going to be doing that. That's certainly something you can do. You can extend this to do that. Maybe if it's really popular, I can make a follow-up on how to do that, but we're not going to be doing that here. Okay, so what we're just going to do is we're going to take this camera. For the purposes of our space demo, I will set up my background to be black, and I'm going to just go solid color so that we get a very nice black background on our camera here. And let me position it in a place that makes sense. So let's go find our camera here. And it's a 0, 0. Where's our sun here? We're operating on objects that are fairly large. Our sun's not at 0, 0, but this will be fine. And we'll use the camera scripts to set the height. So I think it's absolutely fine to keep it 0, 0, but we could certainly, to make it more realistic, move this up here and then rotate around on the scene, and then we'll rely on the actual scripts to set this. So we'll probably set this up maybe 400 height. Yeah, okay. That way we can see the star and the planet. We might tweak that a little bit, but that'll be a good starting position for that. And at this point, we're ready to start adding in our graphs. Now, I use the term graph to mean both flow and state embedded in macro. When I need to specify, I will. I'll try to do my best during these videos, but you'll be able to at least see or read the text, a version of this, and get a sense for what's going on. What I'm going to do is I'm going to add in a bolt state machine on our camera here. And we're going to do that because we kind of have different modes that the camera can be in. There's normal mode where the user can pan around, zoom, and rotate. But then there's follow mode where we don't really want the user panning away from the unit or object that's being followed. And then likewise, if the camera's frozen, then we want to be able to turn that off. So we're going to go ahead and make this, I guess, a macro. That way we can embed it in a prefab or something like that very easily. Let's go ahead and convert that. I'm going to shove this in my macros folder. And we're going to go ahead and call this like RTS Cam or something like that to be consistent with the text version of the tutorial. So there we go. So let's position our graph inspector for the purpose of, bear with me one moment while I configure my windows. Okay, so there we go. I really should have done that before. That's professionalism for you, but basically the scene doesn't really matter much because almost everything we're going to be computing at runtime, the graph is what I really want to highlight for the tutorial. So we're going to put that here, and then when we actually play the game, we'll expand it out so that we can see it. Okay, so what we're going to do is we're going to take our start state here, and we're going to keep it. We're going to remove the starting states, except for on enter state. We're going to leave that one. And we're going to go ahead and leave that as an embedded state for the graph. And then we're going to go ahead and create a few extra states here. Now, Bolt is just fine with you leaving transitions blank. Let's go ahead and show that off. So we'll go ahead and we'll make a transition down into a flow state. And there's no event here. It's going to highlight it orange because it's an error. It's really not, because if you take a look at this, it's just never going to trigger the transition. That's not an error. It's just never going to actually use this transition. There's only one way. We're going to have our start state, and then we're going to move to normal. So let's go ahead and give this a name. We have our normal state, and we'll go in and we'll fix these events here in a little bit. But we'll go ahead and create two other states. So we'll go ahead and create our follow state, and we can go back and forth between those. And then we are going to create transitions to a frozen state, and likewise it's going to be able to transition between both of those. For the purposes of the tutorial, I have on hover and on select turned on. So if I can do this and you can see all of the text. This is not the way Bolt comes configured. If you want to do that, you can go up here to Bolt and say Editor Preferences, and I have mine set to on hover or selected. I believe by default it's set to on hover with Alt, maybe? Not sure, but there we go. So the secret sauce, if you will, for this event, we're just going to go ahead and do this. We're going to wire this up to update. Boom. So that means as soon as the game updates, it's going to transition to normal. That's going to be our starting state by default. There might be some gameplay reason for switching to some other state, but we're going to go ahead and just assume for the purposes of our demo, we're going to switch to normal, and then something else will cause it to trigger a switch to what we should rename as follow mode, maybe just follow. And we have our frozen state. Okay. So what we're going to do is we're going to start in on the start and the normal. That's going to be the bulk of the tutorials. And then follow and frozen are actually going to be pretty short, kind of right at the end of the tutorial. And we're going to focus on a little bit on how these transitions are supposed to work. So one thing that I cover in the text version of the tutorial is that we're making the overall state graph that is present on the main camera. So if I go to my inspector, I can see that I made that a macro, which means it's fine to embed in a prefab, but I can't reference anything from the scene in this entity. That's fine. We don't need to reference anything from the scene, but the macroness of this is kind of inherited. So my state here, if I go back to my graph inspector, is set to be embed. And all of these are embed. And it's actually fine to do this. What this is going to mean is that when Unity serializes our macro here for the RTS cam, that's its own asset. It lives inside your asset structure of your project. It doesn't live inside your scene. So, versus if it was embedded on the object, it would actually live in the object instance that's in your scene. Here, because it's in our asset list for our project, it's going to be serialized that way, and the embedded nodes that are part of this macro will actually be embedded into this asset. So it's actually going to save them as part of it. We are going to create some other macros over the course of this, and I'll try to be clear when I'm creating one versus the other, but just because you made one thing a macro doesn't mean that everything it calls needs to be a macro. Once you have that starting instance as a macro on a state machine, Things that it calls can be embedded, and your only real reason to make them a macro is if you want to reuse them, or you want to reference, or you want to use them in another prefab. Other than that, you're free to leave them as embedded and prevent cluttering up your asset list and your graph list. So go ahead and try to commit that to memory, because we are going to be using that an awful lot over the course of this. So we're actually going to start with a different graph. And my reasoning for this is very simple. I know from experience we're going to need a lot of variables to keep track of our camera's state. And part of that is because we're trying to design a very general camera. So we're going to have to be able to turn on behaviors and turn off behaviors, as well as control the speed at which panning is done, the height limits, the map limits, whether follow mode is on, how fast we need to follow. All these different things are going to be using variables. Now, so how we're going to handle that is, rather than go in here and create a whole bunch of variables like we did in the platformer tutorial, what we're going to do instead is just go ahead and set up a macro for defaulting variables. And I described this in the text version of the tutorial, but it's a little bit messy of a graph. I haven't found a way to make this graph really clean, so it's messy. It is. So let's go ahead and go into our start state. And let's go ahead and, well, you know what? Let's just create it from down here. We're going to go ahead and create a new bolt flow macro for default variable. And we can go ahead and name it that. It's fine to use spaces. Bolt doesn't care. And this is obviously our macro. And what we're going to do is we're going to give it a flow input, and we're going to give it 3 value inputs. And then we're going to give it a control flow output. Okay, we're going to go over why, but let's walk through creating those real quick. We're going to create a input. We'll go ahead and hide the label. And the reason why we do that is, let's go ahead and add one of these to our graph here. If we don't hide the label, we get in. Of course it's in. The only reason to really label it is if you have multiple in something like a macro that you're going to be reusing everywhere. So let's just go ahead and hide that label. And then we're also going to set up a control output. We're going to go ahead and call it something, but we're going to hide the label. And we can go ahead and add that over here so we can see that. And then we're going to need some value inputs. And we're going to need a couple different things here. What our goal here is to default a variable if it doesn't exist. So if the user, you being the user, has gone in here and customized the variables associated with the camera, we want to preserve that. But if you haven't, we want to go ahead and add the variables to the object with some default value that's hopefully useful. And that way we only have to customize what we want, but also it means that you can just drop this graph in and boom, it's functional. You don't have to go through and write out every variable and make sure that they all match and all of that. So what we want to do is we're going to need a variable. Sorry. These 2 inspector things mess me up. Okay, we're going to need a variable. This is the actual name of the variable that we're going to be setting. So that needs to be a string. And we're going to go ahead and check has default value. The reason for this is I can show you over here in our RTS camera. Let's go ahead and call default variable. You can just actually drag it from here. You see this? If I don't default the variable, the only way I can set it is with a string literal where I type in something here. That's really messy. I'd like to not have that because there's no need for it. So if I go in here and I make my variable have a default value, even if it's blank, when I come back out to my graph, I can now type that in here. It's a small thing, it really is, but it really helps declutter a large graph, and we're going to have a lot of default variables, so it's going to be a pretty large graph. Okay. So then we're going to have to set it to a value, and we want that value to be generic. So we're going to change the type to object. Not one of these. Yeah, there we go. It's going to be an object. This is a built-in C# type that just means something that can be referenced and is a chunk of memory out somewhere. And so this can be anything really, almost. even the primitive types like float and int, if you're about to raise alarm bells, because C# can box those up into an object implementation. It doesn't if you just type out int. That's why they're value types and pass by value. But C# automatically handles converting, say, an int to an object. It can do that, and we're going to be relying on that here. Performance overhead is minimal, especially since this isn't our startup. We don't really care. We'll go ahead and make this the summary on this. So this is the value if the variable doesn't exist. Sorry, I have a loud keyboard, but it feels so good. Lastly, we're going to create a target, and this we're not really going to use during this tutorial, but if you want to reuse this script for something else, then that's where this would come in handy. And what this is this is going to be a game object that you want to inject the variable on. And if it's null, then we're going to, or none, as Unity says here, then we're going to take care of setting it on ourselves, the object that is hosting this machine. We're not going to give a default variable to value. Not only can we not do that because it's an object, but also it doesn't really make sense. A default, this whole thing is about establishing what the default is, so we need to pass something there. We can't just allow the user to type that in, unfortunately. So that's it. So we have an input block here with a control flow input as well as 3 variables. So the first thing that we're really going to want to do is make sure that our target is set appropriately. So that's if our target here is null, we want to provide ourselves. That's super easy to do with a null coalesce. There's null check as well, which is a branching behavior, which allows you to take action if there's a null, but we don't need that in this case. Really, we want just a simple self. Feed that in to a null coalesce so we can use the value directly. We don't need branching logic for this. Now, if you're unfamiliar with Bolt, these are grayed out because they're currently not going to happen. Even though we've wired this up, control flow you can think of as this sequence of events. And Bolt does a very good job of inferring what the sequence is. So if I had, let's just add in a branch here. If I had a branch here and pretend for a moment that these were booleans or something, not game objects. If I pass this value into here, you'll notice this now colors in because Bolt has inferred that this needs to happen before this. And it can even do this when things have control flow inputs. So let's say we were instead going to set a variable. So we'll just move this out and we're going to say, oh, this happens here, and we're going to use that output here. It's still, even though this has a control flow in, and we're not saying when to do it, it knows, well, this stuff uses this, and this uses this stuff, so it needs to happen this, then this, then this. Bolt's pretty smart about that, and that's one of the things that makes it so easy to develop graphs, and also to develop really ugly graphs, which I am definitely have that issue. Now, null coalesce I happen to like, because we can use it in macros that don't have a control flow at all. And usually, Bolt's going to figure out what you need to do. But sometimes it doesn't. Sometimes Bolt, due to the way that the control flow is going, it doesn't know that it needs to do something. And so null coalesce allows you to do that without having to force a control flow in. It's just one of those things, you'll get a feel for that. Just keep in mind this guy exists. It's almost like a select, except that it's built in checking for null. Okay, so what we need to do is we need to check also whether our incoming variable, which is defaulted to allow a blank string, is in fact a blank string. And I'm going to do that with a string is null or white space. Is null or empty. You know I'm not seeing it, so let's just go ahead and type it. Is null or empty. Okay, that's going to be fine. Really, I would like it to do the white space. I'm not sure why I'm not seeing that. That's probably because I haven't rebuilt the options in a while, but if that becomes a problem, I'll provide it. Okay, so this is we're going to check and see if the variable value is null or empty, which the default case certainly is. If it is, then we need to do some logic. So let's branch on that and use the output from this as the input to our branch selector. And if it is, we want an error. And we're going to do that using a debug log error. log error, and we're going to use the one that allows a context, because what we can do is we can specify ourself as the context. What that's going to allow you to do is when you have an error, you can click on the console and you can see the object that had the error. It's not going to go straight to the right spot in the graph because this isn't going to create a graph error, but it is going to take you to the object that spawned the error. And we'll use some message here. Something like this. And feed that into our error message. Okay, so the next thing that we need to actually take care of is acting on our value as long as we've gone through this. So we want to make sure it goes through this, so we're setting the object variable on the right thing. So let's go ahead and drag this out. We're going to do variable, object, set object variable, and our target object is whatever our target is, or self, depending on if we provided one or not. And our value for the variable is going to, or not value, but the variable name is going to be whatever was passed in. And then the value of the object that we want to set is, in fact, value. You know what? I actually goofed up. We don't want to set variable. We want a check whether the variable even exists, because we don't want to set it if it actually exists. So let's branch on this once again. And we're only going to do it if we don't error. So let's set up a branch. And then what we're going to do with that branch is then we're going to do our set value. So let's go down here, variables, object, set object variable. And we want to do this if they do not have the variable. So we're going to actually trigger this off of false. And yeah, here's where it gets really ugly. We're going to wire this up. We're going to say the object is this object. Nope, nope, nope. Is that. And the value is what we passed in. Yeah, this got really ugly, and I haven't found a way to really clean it up. You can do a little bit of work here. I did for the pictures in the tutorial. I made sure all these were nice and neat here. But we're going to roll with that. Then what we're going to do is we're going to output, even if we erred, because we want the program to continue. This isn't a fatal error. It just means we couldn't do what we wanted. Go ahead and try to proceed if you can. If they have the variable, then we want to proceed because we don't need to do any actions. And if we did need to do the variable set, then we still want to go ahead and wire that up to the output. So there we go. That is our default variable script complete. It's a little bit ugly, but it does everything that we need it to do. It allows us to specify a target. It's going to check whether the variable exists on the object before it sets its value. It will handle setting the value if it needs to, and it also is error checking. So, looks good. Now we can call this any number of times we need to. We can clone this, and we are going to do this a whole bunch. But this is a reusable chunk of code that we can use going forward. And we're going to do that. One of the things that I know we're going to need is a toggle to control whether the camera is updating as fast as possible or whether it's using the fixed update so it's in time with the physics and things like that. You usually probably want it to update, I guess, in the update, but we want to control that. So we're going to create a variable here, use fixed update. And we'll go ahead and wire that up. And we'll get rid of this one for now. And we're just going to leave it as self. And the value is going to be, let's go ahead and default that to false. So it's going to use the regular update as opposed to the fixed update. But this will go ahead and create that. So we can actually test that. We'll go ahead and select our main camera, go back to the inspector so that I can see my variables here. And go ahead and start up. Takes a moment, and you can see, boom, we have a default here. We have use fixed update is a boolean false. That's exactly what we wanted. Now, if I take this and I go ahead and I add this variable manually, let's say, nope, I want it to true for this scene, and then start up, that value should be preserved because of the code that we set up. And in fact, it is. So that you can see the advantage of doing this allows you to not pay any attention to these variables at all, and valid defaults are chosen. But it also allows you to opt in as the developer to overriding the default value for a variable, and that's going to come come in handy a lot as we go forward, because we're going to, again, use a lot of variables. So that kind of wraps up all of part 1 of the text tutorial. Hopefully I'll be doing the other ones soon in video form, and of course I'll be continuing the text tutorial. If you're interested in the text tutorial, or you just want to go ahead and just download these graphs, see the tutorial. There should be a link in the description if you're on YouTube, and you should find all the information there, as well as the little space scene that I'm using here, which is incredibly basic, and but it will demonstrate the actions. But we needed something moving to show that follow mode. But that's part 1. Hopefully I'll get part 2 done soon, and hopefully I will see you there. Thanks for watching.